Okay, so now we'll discuss about traversing a binary tree. So traversing means visiting every node of a given tree. So let's see how it is possible. So traversing is basically means visiting the every node of the tree exactly one way. So we want to visit every node of the given tree. Now when we talk about traversing, we have different methods of visiting the nodes of a given tree. Here we are discussing about traversing a binary tree especially, right? So binary tree is a tree where we have maximum two child for any given node. So far we have seen that we have linear data structures. So in the linear data structures, we have a sequential axis and we have a defined successor for any given element. But when we say non-linear data structure, then the element can be traversed in many different ways. So tree is basically a non-linear data structures and we have different techniques for traversing or visiting these nodes. So the most popular techniques of accessing these nodes are in-order, pre-order and post-order. So we'll see that how these algorithms actually used to traverse the tree. So the very first is pre-order. So as the name suggests, we have three format: pre, post, and in order. So pre means you can say before, and post means after, and in means in between. So when I say before, after, and between, we are using this in context of the root node. So if the root node can be accessed, if the root node is accessed at the beginning or before any other node, if we are accessing the root node, then that's a pre-order traversing method. If the root node is accessed at the last, then it is called post, and if the root node is accessed in between, then it is said to be a in order. One thing to keep in mind, so we have three things to be considered. One is the left tree, the right tree, and the root node. So we can call it as a n. So L refers to the left tree, R refers to the right tree, and N refers to the root node. Now the position of this will define these orders: pre, post, and in. Keep in mind that when we talk about left and right, the left must always be the first and right must always be second. We will never get any form where R will come before the L. Now, if I make this sequence in context of pre, post, and in order, then you can see that pre means before, so node comes first, this root node comes first, then the left tree and the right tree. If I talk about the post, then first comes the left tree, then right tree, then the root node. And in means the left tree, the root node, and the right tree. So this is something that we have to keep in mind when we will be doing these kind of traversals. So this is a strategy of doing the pre-order traversal. So here what we are doing, visiting the root node. So the very first thing is we have to visit the root node, and then we are traversing the left subtree, and finally we are traversing the right subtree. So this is the pre-order traversal. So if this is given to us, then how we can write the sequence of the traversal. So the very first thing is the root, so this is A. Then we have a left child, this is B. Now because we don't have any further tree extended here, so we simply take this as a left element, and then the right C. So the answer is ABC. If we do the pre-order traversal of this, we get the ABC. So if we look to the post-order traversal of the same tree, then you can see this left means is B, then right, which is C, and then the root, that is A. And similarly, if I do the in order traversal, so left, B, then root, and then right. So this is your pre-order, this is your post-order, and this is your in order. So this is very simply we understood that how the things are working. Now we will go in detail about their algorithm, that how these algorithms can be written to achieve these things. So this is the algorithm for pre-order. So you can see here that repeat the step 2 to 4 while tree is not equals to null. So actually we have to keep on doing this steps 2 to 4 until tree becomes null, and the tree is going to become null unless you visit all the nodes. So once all the nodes have been visited, it will stop. So keep in mind, when we say pre-order, pre means first comes the root node. So I am calling it as an N, then left, and then right. So actually here, whenever you whenever say pre, post, and in order, it actually always used in context of the root node, and this is the node that we are actually displaying it. So here you can see, if you look at this, this is what that we are displaying, and the left part and the right part we keep on actually calling recursively. So this is a recursive algorithm where we need to pass our tree, and when you pass your tree, you are actually passing the root node. So already we have discussed that we are implementing the tree, then we have to maintain one pointer tree which actually points to the root of the given tree. So the very first is you write the data which is pointed by a tree, that is you need to display the root node, and then you need to call recursively the left subtree. So first you will print this, and then you have to work on this tree, and finally when this tree is finished, then you have to work on this tree. Now because this is a recursive algorithm, and with every tree we have a lot of subtrees are there, so when you move to this tree, then this is actually your new problem. So you take this root, and then you have to work on this tree, and this is your right tree. And when you call on this subtree, you have to take this root, and you have to work on this tree. So every time you are taking the root value, and then first visiting the left subtree and then the right subtree, as here you can see here, the root, the left subtree, and the right subtree. So how we can process this algorithm to get our final answer? So let us see. Okay, so here this is the answer given to us, but how we get this answer? Let us trace it here. So the root, we will take it this A, and then it will move towards the left. Okay, so you take this, and then you come here. Now this you have to take. So here you can see this is your new tree, and you have to take the root of this tree. So you take B, and then again you have to keep on moving because this is a recursive function. So when you go to this subtree, it will again make a call for this left subtree. So again you will be printing this root value D, and then this will again call it subtree. So this you will get it here, and here we have no left child, right child, so you have to stop here, but you have to print this node, the root node G. Now if you look here, when you keep on moving from here to here to here, now this is your tree, so you will print. Now if you remember this is A, B, and C, and when we say a pre-order, we take the root A, and then the left child and the right child. So this is the answer. Now here you can say this is your tree, here this is the root, so you take you have to take the G, and there is no left child and there is no right child, right? So your now you are going back because this is a recursive call. Now you are working for this tree, your this is already you have taken D, this left child is finished. Now you have to work on the right child, so it will call recursively the right child, means this will keep on working pre-order right tree right. So here when you call this is again a new tree. Now this is acting as a root, so you have to call H, and then you have to look for the left child. So there is no left child, so you will look to the right child, so that is L. Now we have already finished this entire left child, so the root is finished, left child is finished, and then we have to traverse the right child, that is E. Now this entire tree has been processed, we have been traversed this. So keep in mind we are doing node left right, so node has been processed, this entire left tree has been processed. Now we have to move to the right tree. So when you pass this tree for processing, so this becomes the new tree that we have to work on. So this is your root, so C, and then you have to look to the left child, there is no left child, so there is nothing to be done. Then you will look to the right child. Now when you pass this right child, this is again a new tree, so this becomes the root F, and then you have to pass to the left child, which is I, and then there is no left and right child. So the left child has been processed. You go to the right is J, and then you have K, and then you will stop because all the things have been processed. So you can see that this is our answer: A, B, D, G, H, L, E, C, F, I, J, K. So if you are doing the very first time, it may look like a little confusing, but I'm very sure that the moment you can practice with the 2-3 examples, it will be very easy for you. So let us take one more example to understand in a better way. Again, before you start, always it's good to write this format: node, left and right. Means every time when you take any input, every input will be acting as a tree. So with every tree you have to apply this rule: node, left, right. So initially we have this tree. So node, we have to print this. We have to print only the node type. Only the node can be printed, and this is only for recursive call. So you print A, then you have to call the left subtree. So this is your new tree. Now in the new tree you have to print the root node. This is root B, and then there is no left tree, so there's nothing to do. Then you go to the right. So in the right we have only this option, so D. Now, so we have processed this entire tree, has been processed. All the nodes have been accessed, traversed, and if you look to the entire tree, we have already taken this. This is finished, and then the left child is finished. Now you have to move to the right child. So if you move to the right child, what you will get? So this is your new tree which you have to work on. So again, whenever any tree is passed, first we have to take the root node. So you will write C, and then you have to pass the left subtree. So left subtree means this tree has to be being passed as a recursive call. Again, when you look at this, what you will find? You will find E, because it's the root, and then you have to check any left child is there. There is no left child, so you go to the right. So you have a new tree. This is a new tree where you will get, this is a root node. You write F, and then you have to go the left child. So left child is again a new tree. In the new tree, this is your root node. Then left H, and then you have a right. So this is the example: A, B, C, D, A, B, D, C, then E, F, G, H, I, and this is what we have written here: A, B, D, C. This is a mistake. This is not, because D cannot be traversed 2 times. This is wrong. So answer is A, B, D, C, E, F, G, H, I. This is how we can do the pre-order traversing. Similarly, we have to apply the same kind of principle, but to keep the ordering in mind, that when we go for the other kind of ordering, we need to simply take care that where this root node exists. Okay, let us move to the next part. Okay, now there is one important result, or you can say the very important application of the pre-order traversing. Now this is used to extract the prefix notation of any expression tree. We already seen that binary tree has been used for representing any expression. So if the expression tree is given to you, and with the help of pre-order traversal, you can get the prefix notation. So already we have discussed in the previous slides, in the previous discussion, we have seen that this is one expression given to us, and we have converted into the expression tree, and this is also one expression tree for a given expression. Now if we do a pre-order traversal, we can get the prefix of that given expression. So if you look at this, and you can find that if I apply this rule NLR, so node, that is plus, then we have to move to the left subtree, then minus, then A and B, and then go to right side, multiply CD. Similarly, you can find here, this is your root, so divide, and then you can find minus. Then again you have to call to the left child, that is the left subtree, plus AB, and then into CD, and then you have to go to the right child, and then again this is a new tree, so divide, and this is a power operator FG. So yes, you have to make some changes here. This is a mistake here. This is actually E, F, G, and H. So here you can find that this operator EF, then we have minus GH. So this is a uh, prefix notation of a given expression. So if you are asked to convert any expression into a prefix expression, already we have discussed an algorithm to converting any infix to prefix. But the other way of converting to prefix is you can first convert into a expression tree and then do the pre-order traversing. You will get your prefix notation. So this is also one way of doing it, to converting the infix to prefix. Okay, so let's move to the next. Next type of traversing method is called in-order traversal. As we have already discussed, in order means in between. So just keep in mind, now we have to do this thing: left node, right. Means we have to keep on traversing our tree uh, in this fashion. We have to keep on moving toward the left subtree, and then at the last we have to print the root node. So keep on traversing to the left subtree and then print the root node, and then keep on moving to the right subtree. So traversing the left subtree and then visiting the root node, and then finally traversing the right subtree. These are the three things that we have to do when we talk about in order traversal. So let's see that how it can be implemented by using one example. So this is the algorithm for in-order traversal. This is again written recursively. Here you can see that it's very similar to the pre-order. The only thing is we have to keep in mind and we have to change this order: left node, right. So we have to keep on doing these 2, 3, 4 steps until we access all the nodes, until we traverse to all the nodes. So, or you can say until the tree is not equals to null. So we have to keep on traversing to the left subtree. We are writing this as an in order tree left. So tree is a pointer that points to the root value. So we have to move to the left subtree. We keep on moving, and when you are going to stop, you have to write the root node. So you keep on traversing to the left subtree, and then finally you have to write the root node, and then you have to also traverse to the right subtree. Now, so if I apply this logic, so we have to start from here. Now, in the previous case, we have written this root, because in the previous case, when I say pre-order means this is node left, right, and keep in mind we are only printing this part. This part is only used. This is only used to make a recursive call. So here also this is for recursive call, and this is something that we use to print. So when we start with the pre-order, the very first value we have to print, and then we start doing a recursive call. Now here first we have to make a recursive call. So you are here, you have to keep on moving toward the left subtree. So when you are provided the tree with the address of this node, you have to move to the left subtree. So you will traverse to this subtree. Now again, this is again a tree, and again you have to follow this principle: left node, right. So again you will look to the left child. This is your left child. Again, this is again a tree, so you have to again go to the left subtree. Now this is what you left. Now here at this point, now there is no more extension. You are not allowed to move to any further left subtree. So there is no left subtree. So what is left? This is done. Then print the node. So means if you look at this tree, so we have, this is the left child we have accessed, which is nothing. Then the node, then the root of this tree. So this is G. And then the right, there is nothing on the right side. So now we have finished. Now if you look at, now because it's a recursive call and you are returning back to the function which has been making a call, so this has been executed completely, it will return back. Now this is a part of, this is a left tree of this bigger tree, right? So we have now processed this left part. Now you return to the root. So this is your root for this tree. So you will print here D, and then you move to the right subtree. So this is the right subtree. Now when you move to the right subtree, again this is a tree, so you have this will act as a root, and then you have to look to the left subtree. So there is nothing in the left subtree, so you have finished this left part. You will return back to the root node. This is H, you have to print, and then you go to the right subtree. Now this is your right subtree, this is a new tree, and here you can find there is no left subtree left. So you have already processed this recursive call, so you will go back to the root node, which is L, and there is no right subtree. So we have already finished this entire tree, is already been accessed. Now we are moving back to the outer tree. Now this is the tree which is existing, means after this tree. Means this is you can say an inner tree. This is the subtree of this tree. So it return backs. Now you have already processed this entire left subtree for this tree. I am talking about this tree. So the entire left subtree has been processed. You return to the root. So root need to be displayed B, and then you move to the right subtree. And the right subtree, we have only one node. So when you have only one node, you simply print here, because we don't have any left and right. So there is no chance to move to any further nodes. Now, as a whole, this entire tree has been processed. So now, if you look at this in this bigger context, so we have already traversed this all the nodes of the left subtree. We have to now print this node, this root we have to print. So this is A, and then you are calling a right subtree. So now you have to work on this subtree. So when you work on the subtree, so let me make a little clear here. So just understand here that we have already finished this tree. We have already processed this tree. Left is already done. Node already processed. Now we are working on this part. This is the part that we are working on. So again, this is the new tree. In the new tree, you have to this will acting as a root. So you have to first look to the left. There is no left, so you go to the root. Root need to be printed. You print C. Then you go to the right. Now this is your new tree. Now when you go to the new tree, you have to move to the left first. You cannot print the root. So you go to the left. Left is this. Again, this is your new tree. Because this is the only node in the tree, so you simply print this node I. Now the entire left subtree has been processed for this bigger tree. So you have to look to the root node. So F, and then you go to the right subtree. In the right subtree, this is your right subtree. So this is your root node. You go to the left. This is K, and then J. So this is our answer: G D H L B E A C I F K J. So I hope you have understood that how to process or do traversing in the in-order traversing method of any binary tree. So let us take one more example for this tree and see that how we will get the sequence for this particular given tree doing in-order traversing. So again, always keep in mind that we are doing left node right. When we talk in order, this is left node right, and we are talking about this tree. So again, we start with this root node, but we have to first process the left subtree. This is our left subtree. So again, when this tree is being passed, this is acting as a root. So we have to look to the left subtree, which is nothing here. So you will simply print the root and this root node. So you have processed the left subpart, and then you move to the node. So this need to be printed B. Then you go to the right subtree, which is the only node. So when we find only node, simply print it. Now the entire left tree has been processed. So the entire left tree for the entire graph has been processed. Then we move to the this node, which is a root. So print it here, and then we will work on the right subtree. This is your right subtree. So again, this is your root node. We will don't print this, but we have to move to the right to the left subtree. So moving to the left subtree, this is your left subtree. In the left subtree, you need to, again, this is the root, so you have to look here. There is nothing, so you print this E, and then you again call the right subtree. In the right subtree, this will act as a root, so you have to look to the left subtree. Again, this acts as a root, so you go again further left subtree. This is the only node, you write H. and then you go here G, and then now I'm assuming that you understood that what I am doing and how these nodes are being printed. So I have processed the left, then node, and then right, and then I. So the entire left has been processed. So you go to the root. So this is F, and now this entire tree has been processed. So you know, go to the root. This is C, and there is no right child, and now the entire tree has been processed. So you can see here, this is the final answer: B D A E H G I F C. This is what it is given here. So likewise, for more practice, you can just draw a tree from your side. Any tree you can make, means any structure you can make of binary tree, and then yourself you try to traverse in the in order, post order, pre order, to have a better understanding. Okay, so now we will move to the next traversing technique. Then next is a post order traversal. So again, let me write here. Let this is left, right, and the root. So we will keep on traversing the left subtree, and also we will first traverse all the right subtree, and then finally we print the root of that tree. So this is how we are doing. So traversing the left subtree as we have written here, and then we are traversing the right subtree, and finally we have to print, or you can say visit, the root node. So we will see that how the things will work. We will take the algorithm of this. So here is the algorithm of doing a post order traversing. So you can see here it's almost the same kind of recursive procedure. The only difference is here we have to first traverse the left subtree, then the right subtree. You can see this is a recursive call for the left subtree. This is a recursive call for a right subtree, and then finally we are visiting the root node. Okay, so let us apply this algorithm on this particular given tree. This is a binary tree. So this is the tree given to us for traversing. So when I say tree is given to us, that means we are provided with the root node address. So we need to first traverse the left subtree. So again, when you are given this tree, you have to move to this subtree, and again this is your new problem. Now you are working on this subtree. So again, whenever any tree is given to you, you have to move toward the left. So you will be working on this subtree. So again, this is a new tree. You have to work on this tree, but again you are doing a recursive call, so you will be doing on this tree. Okay, so at this point there is no option to move further. So you will look what is the left. There is no left, and there is no right. So we have to process all left. There is no left. Then we look what is the right. There is no right. Then you go back to the root node and you will print this. So you will get G here. Now we are back. Now this is your innermost tree. This is the smallest subtree. So you need to go back to the tree for which this is a subtree. So this is a tree for which this is acting as a subtree. So we have already processed the left part. This has already been processed. Now we have to go to the right part. That means we have to process this thing. Just to refer here, in order, after finishing this left subtree, we went back to the root node and we have printed, because in the previous case we have L N R, but now we have left right node. So instead of going back to the root node, we have to process the right subtree. Now this is again a tree. So again, whenever a tree is given to us, we always follow the same principles. Every time we have to look to the left. So you will look to the left. There is no left, so you look to the right. So right is this. This is the only tree. So whenever only a node is given as a tree, you have to simply print that node. So we have processed the left, we process the right, and then we have to go back to the root node. So then for this tree, we have to process the root of this tree, and this is H. Now we have processed this entire left tree has been processed, the right tree has been processed. Now you have to go back to the root of this tree. So the root of this tree is D. You will print D here. Now we have processed this entire left tree of of this tree. Okay, so let me make it a little clear here. So if we talk about, if you consider this tree, already this part has been processed. So the entire left tree has been processed. Okay, then we will, because we are talking about this tree now, so in this tree the left part has been processed, so we have to go back to the right. So when you go to the right, this is the only node, so you have to process it, means you have to print it here. And now for this tree, left is processed, right is processed, then we have to go to the root is B. Now we'll go back to the our outer tree. So this part has been processed, all the nodes have been printed here. Now the left has been processed, now you have to go to the right. So right is this part, so now I'll be making like this. So this part has been processed, you have to process this, because for our entire tree this is the left part which has been done, and then we have to do right. So when you go for the right subtree, again this is a tree, and at every time we have to keep in mind we will be doing in this way, left, right, and so left, right, root. So here you can go to left, there is no left, so you go to right. Now when you go to right, in the right again this is your root, you go to left, so left there is nothing. So sorry, in the left we have I, and in the I, when you go further, this is the only node, so you print it here. And then you go to the right, in the right you will find this tree, and in this tree you have to go to left, this is K, and then you have to go to the right, there is nothing right, so you go back to the root, this is J. So we have already processed the left, the right, and we go back to the root, which is F. And so now if you look to this particular tree, the left has been processed, the right has been processed, so you go to the root, which is C. Now for the main tree, for our main tree, the entire left has been processed, right has been processed, so you will go to the root, which is A. So here you can see our answer is G L H D E B I K J F C A. This is how we can do the post order traversing of the given tree. Let us take one more example. So we have actually taken the same example, and we have tried to process both the trees in the pre-order and the in order. Now we will also try to process the same tree in the post order. So let's see that how we'll get the answer. So again, the very first thing is right, left, right, root. Now this is node, means the root that we have to print. Okay, so we start from here. When you start from here, we have to go through the left tree. Again, this is your root, go to the left, nothing is there, so go to the right, this is the only node, print here D. Then left finished, right finished, go to the root, this is B. Then left finished, this entire left is finished, go to the right. So when you go to the right, actually we are working on this tree. So again, go to the left. So now I assume that you have understood that how the things are working, so I'll be doing little quicker. So we go to left, and then again left, there is no left, so you go to the right, and again this is a tree, you go to the left, and go to the left, there is the only node, so H, and go to the right, I, go to the root, G. Now for this particular tree, the left has been processed, right there is no right, so go to the root. Now for this tree there is no left, the entire right has been processed, to go to the root, E. Now for this, the entire left has been processed, go to the right, there is no right, so go to the root, C. Now for this tree, the entire left has been processed, right has been processed, so this is A. So keep in mind, whenever we are doing the post order traversal, the root node of the main tree will always be at the last. So you can see here, when you are working with this tree, your root node is at the last, and here also this root node is at the last. So the answer is D B H I G F E C A. So I believe now you have understood that how to do traversing using in order, pre-order, and post order. And these different type of traversing are used in different type of scenarios that we will discuss later also. So this is all for binary tree traversing. In the next lecture we are going to talk about a binary search tree, and in the binary search tree we will be using these traversing method and see that how these traversing will help us to deduce some important results. So this is all for this lecture. Thank you very much.